In this video, we're going to take a look at something called formal charge. The formula for finding formal charge is, so the FC is my abbreviation for formal charge, is equal to the normal number of valence electrons that the element that you're finding the formal charge for. So it's the normal number of valence electrons minus half of the number of bonding electrons plus the number of non-bonding electrons. Now this is a quantity that's encased in parentheses, so you have to remember your order of operations. You add these before you subtract it from your normal valence number. So I've got 4 different examples already written down. So let's go ahead and start with the first one. The first one is an organic molecule called methane. It is a hydrocarbon. But if we want to go ahead and find the formal charge for the hydrogen, we would do this. So the formal charge, so I'll put FCH for formal charge for the hydrogen, is equal to the normal valence of normal number of valence electrons that hydrogen normally has is 1. So if we look at this, half of the bonding. So if we look at this, remember we said that a line represents 2 electrons or an electron pair, and this is the pair that hydrogen is sharing with carbon. So these are referred to as bonding electrons. So there are 2 of them, so half of 2 is going to be 1. So this is 1 minus 1 in the parentheses plus the number of non-bonding electrons. Well, hydrogen doesn't have any other electrons that it's not sharing or bonding with anything else, so that is going to be 0. So 1 plus 0 is 1. 1 minus 1 is going to give me a formal charge on the hydrogen of 0. So if I look at my carbon, so I'll say FC, formal charge for my carbon, is equal to, carbon normally has a normal valence number of 4, and half of this, so that's minus half of the bonding. Well, carbon has 1, 2, 3, 4 pairs, so that's 8 total electrons that it's bonding. So half of the bonding electrons, half of 8 is going to be 4. So I'm going to say 4 plus non-bonding. Well, carbon doesn't have any electrons that it's not sharing with other elements, so that's going to be 0. So 4 plus 0 is 4, and 4 minus 4 gives me a formal charge on the carbon to be 0. And one thing that you'll notice over here, there was no charge on my CH4. If you look down here at the SO4, there's a -2 here, or if you look over to the NH4, there's a +1 here. But for the CH4, the basic overall charge is 0. It's neutral. There's not a charge. And we can double check our work to make sure we did the formal charges correct is when we add the formal charges for all of the atoms. Hydrogen is going to be, all the formal charges on each one of these hydrogens are going to be 4, or is going to be 0. So this one is 0, that one's 0, this one's 0, and the one on the right is 0. So add that to the formal charge of 0 on the carbon, and 0 plus 0 gives me my 0 neutral charge for this particular molecule. So let's go over to this molecule, Cn-1. This is actually cyanide, and I already have the Lewis structure drawn out here. But let's go ahead and find the formal charge on carbon. So I'm going to say, I'll try to squeeze this over to the left. So formal charge on carbon is equal to, it normally has a valence number of 4 minus, should be a parenthesis, let's try that better. So parentheses. So 4 minus half of the bonding. Well, carbon has 1, 2, 3 pairs of electrons that's bonding. So that's 6 electrons, 3 pairs, but 6 total electrons. So half of the number of bonding, half of 6 is going to be 3. And we're going to add that to the number of non-bonding. Well, this time carbon actually has 2 electrons that it's not sharing with the nitrogen. So that's going to be my 2 there. So if I do this, 3 plus 2 is going to be 5. 4 minus 5 is going to be -1. So the formal charge on this carbon is -1. So if we look at the nitrogen, so we'll do the formal charge on the nitrogen. A nitrogen has a normal valence number of 5, so we're going to subtract that from half of the bonding electrons. So it's got 1, 2, 3 pairs, so that's 6 bonding electrons. Half of 6 is 3, so we're going to say 3 plus the non-bonding. Nitrogen has 2 non-bonding electrons on the right, so that's going to be +2. So 3 plus 2 is going to give me 5, and 5 minus 5 is 0. So if you'll notice, if I add a -1, which is the formal charge on the carbon, to the formal charge of 0 on the nitrogen, I actually get the -1 charge here for this polyatomic ion, which is cyanide. So like I said before, this is just a way that you can double check to make sure that what you've done actually is correct. So if we go down to this example, SO4 -2, once again this is a polyatomic ion and the name of this is sulfate. So let's just do the charge on this oxygen. So the formal charge on oxygen is going to be, it has a normal valence of 6, and it has 2 bonding electrons. Half of 2 is going to be 1, and it has 1, 2, 3, 4, 5, 6 electrons that are non-bonding. So 1 plus 6 is 7. 6 minus 7 is going to give me the formal charge on oxygen is going to be -1. So let's calculate the formal charge on sulfur. So the formal charge for sulfur is going to be, sulfur has a normal valence number of 6 electrons minus half of the bonding. Well, I've got 2, 4, 6, 8 bonding electrons. Half of 8 is going to be 4. And I add that to the non-bonding. Well, sulfur does not have any extra electrons that are not bonding, so that's going to be 0. So 4 plus 0 gives me 4, and 6 minus 4 gives me a formal charge on the sulfur to be a positive 2. Well, you might ask, well, if I add 2 to a -1, that gives me a positive 1 and not the -2 here. But you have to remember, when you calculated this formal charge for oxygen, you were only counting the formal charge for one of these oxygens, and there are actually 4 of them. So if I took this charge and multiplied it by the 4 oxygens, that's actually going to give me a total -4, and now when I add that to the positive 2, I actually do end up with my -2 that you see on the molecule. So the last example that we are going to look at is NH4. This is a polyatomic ion also. It's called ammonium. So let's calculate the formal charge for the hydrogen. So I'll do this down here. So the formal charge for the hydrogen, and this FCH, this is just kind of a notation I've made up. You may not ever see this anywhere else other than these videos or when I teach it in class, but this just kind of helps me to keep it straight what I'm actually looking for. So FCH, so like I said, you may see this, you may not. I've kind of made it up as my own little way of keeping things straight. But anyhow, so the formal charge for the hydrogen normally has a valence number of 1 minus half of the bonding. Well, it has 2 electrons that are bonding, so half of 2 is 1. It does not have any electrons that are non-bonding, so that's 0. So 1 plus 0 is 1. 1 minus 1 gives me a formal charge on my hydrogens as 0. And if I do my nitrogen, so the formal charge for nitrogen, and I'll put this down here. So nitrogen normally has 5, so we're going to subtract that from the or half of the bonding. The bonding is 2, 4, 6, 8 electrons. Half of 8 gives me 4, and I'm going to add that to the non-bonding. Nitrogen doesn't have any electrons, that's not bonding, so that's going to be 0. So 4 plus 0 is 4, and 5 minus 4 is going to give me a positive 1. And this, when I add a positive 1 to a 0, I actually get the positive 1 that's here. One thing I want you to be careful of, though, hydrogen is often going to have a formal charge of 0. I'm kind of reluctant to say that it will always be 0. There may be other exceptions where hydrogen doesn't have a formal charge of 0. I can't think of any off the top of my head that you guys would actually see in this class, but just keep aware that hydrogen isn't always going to be 0, so it's a good idea to go ahead and calculate what hydrogen is going to be. And just because, like for example, in the SO4 -2, each one of these hydrogens, or not hydrogens, but each one of these oxygens did have a formal charge of -1, but that's because all of them had 6 non-bonding electrons and 1 bonding pair of electrons. So if you ever have a situation where you may have, let's say, if you've got, let's just make up something, say, you've got an oxygen that's maybe double bonded to something else, and on this side of the problem you may have an oxygen that's single bonded to something else. Even though these are both oxygen, they're not going to have the same formal charge because I've got a double bond here and I've got a single bond here. In order to just say that the formal charge is exactly the same, you have to make sure that everything is the same. So like we said, an oxygen here has 6 electrons that are non-bonding and a pair that's bonding, and each one of these oxygen is described by that. But in this example that we've kind of made up, let's just call this X. It could be bonded to whatever. But this oxygen is double bonded to this X, whereas this oxygen is only single bonded. And in this case, this oxygen number 1 and oxygen number 2 won't have the same formal charge. But anyhow, I hope that helps to make it clear of how to calculate formal charge after you've written the Lewis structure. But you need to make sure that you have correctly written the Lewis structure first, or else your formal charge calculation may not be correct.